Hello. This pre-recording is to replace the lecture that I would normally give on Wednesday, September 16th. Since I will be in the doctor's office instead of here, I'm pre-recording this lecture, and of course, it's posted in Canvas. This is for statistical literacy for both of my sections. And it's on chapter 4, which is on sampling. So I'll be going through the PowerPoints for chapter 4. I will be posting the PowerPoints also. And so here we go. So I'll start sharing the screen for the PowerPoints. All right. So let's get started. All right, so sampling. Sampling is a statistical method that we use to acquire from a population a subset of the population. So we can try to, and the results that we get from the sample, our goal usually is to say something about the population. All right, so let's just think a little bit about survey versus an experiment. It asks here, what do you think is the major difference between a survey and an experiment? Let's see if they come up with an answer. No answer yet. Second question, suppose a properly chosen sample of 1,600 people across the US was asked if they regularly watch a certain TV program, and 24% said yes. How close do you think that is to the percentage of the entire country who watch the show? All right. Exactly, is it going to be within 30% of the true, is the 24% going to be close to 30% of the actual true percentage? Is it within 10%, 5%, 1%? Is it exactly the same? Think about that. Question 3, many TV stations conduct polls by asking viewers to call one phone number they feel one way about an issue and a different phone number if they feel the opposite. Do you think the result of such a poll represents the feelings of the entire community? Do you think they represent the feelings of all those watching the TV station at the time, or the feelings of some other group? Question 4, suppose you had a telephone directory listing all the businesses in a city, alphabetized by type of business. You wanted to phone 100 of them to get a representative sampling of opinion on some issue. How would you select which 100 to phone? Why would it not be a good idea to simply use the first 100 businesses listed? Question 5, there are many professional polling organizations such as Gallup and Roper. They often report on surveys that they have done, announcing that they have sampled 1,243 adults or some such number. How do you think they select the people to include them in the survey, in the samples? All right. So those are the types of questions that will be answered in this chapter. Now let's just take a look at number 1, question 1. I think we can answer this now. What's the difference between a survey and an experiment? Well, a survey is where you would be basically asking people their opinion, or asking them questions without trying to control what the answers are going to be. An experiment is really an artificial situation that a researcher sets up to control variables. So that's the big difference between a survey and an experiment. Survey, no control, you're just asking questions. An experiment is all about controlling variables. Okay. Now this question here about how close does a sample get to the true population percentage? That's a question that takes a little bit of mathematics to answer. But we're going to be talking about something called the margin of error, and that will determine how close you can be. All right, so we'll get to that when we get to margin of error. Just keep that in mind. Do you think a poll represents the feelings of the community? So the conduct polls by asking viewers to call one phone number if they feel one way or the other. Well, is this a scientific poll, or is it sort of a volunteer poll? Well, that's what we're going to talk about also. How about a telephone directory? If you wanted to phone 100 of the people in a certain city, how would you do it? Would you just select the first 100 people in the telephone directory? Is that a good idea? Well, what's the answer to that? Not such a great idea. Now we'll learn why in a little bit. How do you think they select people to include in their samples? Well, there's different sampling methods that we're going to talk about in a few minutes. So that will answer this question a bit. All right, common research strategies, sample surveys. And that's what we're going to be dealing with mostly in this course. Now, the question you might ask is, why not experiments? Well, the reason in general is that experiments are more difficult to design and more difficult to understand. That's number one. And number two, depending on your field of study, psychology versus biology, the research methods may be different. So typically, if you are in a certain major in college or graduate school, and you're studying how to do statistics for your field, there will be a course called research methods, which will go beyond the introductory course in statistics, and will be used in those particular research methods include the types of experimental methods that are used in that field of study. So it's sort of an advanced topic, experimentation. And so we're going to stick mostly with sample surveys when we describe statistics. All right, so sample surveys is a subgroup of a large population in which you question people. In general, at least it should be, that there's no intervention or manipulation of the people who respond. You're simply asking them to answer questions. An experiment is, you are manipulating the environment in some way. You're trying to control the circumstances. How do you do this? Well, you do it through a process called randomization, or a randomized experiment. You randomly assign participants to treatment groups. That's what you're doing. For example, if you have, I think we saw this before, if we had a certain group of people who were going to be given aspirin to see if heart attack rates go down, and other people would be getting what's called a placebo, which is something that looks like aspirin, but has no active ingredients. Then if you randomly, and in an experiment, you would randomly assign people to these two treatment groups. And the whole idea is that when you do that, the two groups are pretty much are very similar to each other with respect to other factors, such as age and gender and things like that. Another term here that's used in experiments is explanatory variable. That's the variable that you are manipulating. For example, if it's aspirin versus a placebo, that's the explanatory variable. The response variable is the outcome of interest. In the case of the experiment with aspirin, you want to see if heart attacks go down. So the rate of heart attacks is your response variable. All right. And once again, randomization helps to make the groups approximately equal in all respects except for the explanatory variable. So, and why do you want to do that? It's because then you can talk about cause and effect. You can say, all right, now the results of my experiments are showing that aspirin causes a decrease in heart attacks. You can actually talk about one variable causing the other. In an observational study, you can't. That's because you're not controlling for these other variables. It says here manipulation occurs naturally. If you may even say there's really no manipulation going on. Okay. And you can't assume that the explanatory variable is the only variable affecting the response variable. You're not controlling for it. Right? Now, there are attempts to do that in what are called case control studies. But in general, observational studies, you cannot talk about cause and effect. You can talk about two variables correlated with each other, associated with each other, but not, you can't necessarily say one causes the other. And one thing you can do in an observational study is that whatever the results you get, if you take a random sample, you may be able to extend the results to the entire population. In an experiment, normally the people who are the participants in the experiment are normally volunteers. And because they're volunteers and not randomly chosen from the population, it's more difficult to take your results and generalize those results to the larger population. Meta-analysis. Now, there's a chapter later on in the book about this. I don't know if we'll actually get to this topic. But in general, a meta-analysis is a quantitative review of many studies on the same topic. All right? So this is basically some way of taking a look at studies that have already been done on the same topic, and then coming to some conclusion. So that's the definition of a meta-analysis. That's pretty much all you need to know for this course. All right. Case studies. Sometimes case studies are done. Typically, it's either one person that you're talking to or examining, or a small number of people. This is not really a statistical study. It's more descriptive. You might be asking them questions and they're giving you these very long answers. So really, you can't extend this to the larger population, whatever you find out. However, it's useful to have studies like this so that if you're not sure which variables to test in a future study, this type of case study can actually give you some clues about that. All right, let's look at some examples of these different types of studies. Experiments versus observational studies, just so that, again, hopefully you'll be comfortable in being able to distinguish when you read something, whether it's observational or an experiment. For example, if you look at news story 20, it says eating organic foods reduces pesticide concentration in children. Notice that the title implies cause and effect, that eating organic foods affects, or reduces in this case, pesticide concentration in children. However, it's an observational study. Why is it observational? Because parents kept a food diary for their children for 3 days. The researcher didn't do anything, didn't try to control what the child was eating. So the parents kept a food diary, basically a written list or something written about what the child ate during those 3 days. It says here, the result, there was a difference for children eating organic versus conventional produce. You notice the difference. Now, what's the plus about this type of study? Well, it was done in their natural environment, right? It wasn't in some laboratory. What's the minus? You can't determine if the difference is due to the food. So in other words, if there was a change in pesticide concentration in children, there might be some other factor that produced that and not the change in the diet. And again, this is an observational study, so you're not controlling for other possible variables that could influence the pesticide concentration in children. Number 3, news story number 3. This is an experiment. This rigorous veggie diet found to slash cholesterol. Volunteers randomly assigned to one of 3 diets. A reduction in cholesterol measured and was compared. All right, so we wanted to, depending on which diet was given, we wanted to see if cholesterol went down. What's the plus of the study? Because it's a randomized experiment, right, and we're assuming here there was a control group, then the groups were approximately the same in all other factors except for what? The diet they were being given to eat, either the veggie diet or some other diet. All right? So you can talk about, in this case, cause and effect. On the other hand, it says, would anyone really follow the diet in the real world? Would anybody really do this? Is it in a natural setting? But another thing I wanted to bring to your attention is volunteers. Volunteers randomly assign 1 of 3 diets. Since the people who participated in the study were not randomly selected, they were volunteers, whatever was found in the study, it would be hard to generalize this to the entire population. So let's talk about some terms that are used here, and these terms are words that you should know for the very first quiz, which will be on Monday the 21st. So whatever we're covering today will be included. The first 4 chapters will be included for that first quiz, which is just basic definitions and concepts. So what is a unit? Well, it's a single person or object to be measured in a study, whether it is an observational study or whether it is an experiment. Population is the entire collection of units about which we would like information, or we can also define it as the entire collection of measurements that we could get if we measured every unit in the population. Sample is a collection of these units that we're actually measuring. All right, so it is a subset of the entire population. And here's a phrase: sampling frame. What is a sampling frame? It's really the list of all possible units that seemingly represent the population and from which we choose the sample. Now think about in terms of in a city or town, all right? We want to take a random sample of people who were residents of a city or town. Well, how would somebody do that? Well, if there was an actual list of everybody who was in that city or town, that would be the sampling frame. But sometimes that sort of list is not available, so we have to use some creativity and come up with another list that might be as similar as possible to a list of all people in the town. We might get it from the tax collector or some agency or whatever. But the sampling frame is the actual list of possible people in the population that we're interested in. And sometimes the sampling frame is created from multiple lists. In a sample survey, measurements are taken on a subset or sample of units from the population. All right, that's what I said earlier. And here's a definition: a census. A census is a survey in which every person in the population is measured. All right. So a sample survey is a subset of the population that's measured, and a census is one in which everyone in the population is measured. So let's look at an example in terms of these definitions. The Bureau of Labor Statistics visits approximately 60,000 households, chosen from a list of all known households in the country. And notice they visit households, not individuals. All right, this is actually their sampling frame, households. Each adult classified, in other words, now we're going to look at whether there's any, who are the adults in that household. Each adult is classified as either employed or unemployed, or not in the labor force. And then there's a calculation made, which is called the unemployment rate. Who are the units? The units are the adults in the labor force. These are the people who are actually being measured. Now, household isn't being measured. The adults are being measured. And what are they being measured on? Whether they're employed, unemployed, or not in the labor force. The population of these units are all adults in the labor force. Hopefully makes sense, right? That's the population, all adults in the labor force. If we were going to look at the population in terms of measurements, we would look at the employment status of everyone in the labor force. But the sampling frame is not adults in the labor force. It is a list of all known households in the US. Now, why? And the reason for this is that there's no list out there in the United States, and for the whole country, of all people in the United States. There's just no list. So the Bureau of Labor Statistics came up with, created a list of all the known households in the United States. And that is, from that, what are we going to be doing? Well, we're going to be somehow choosing households, and then from the households, we'll be taking a sample of units, the actual adults within that household. That sounds kind of complicated, and it is. It's not an easy task to do all of this. All right. Sample of measurements. We'll be taking a sample of people's employment status in the sample, in the subset. Now, why is sampling such a wonderful thing? Well, number one, you can't always, and in most cases, if the population is large, you're not going to be able to talk to everyone in the population. Sometimes it's just not possible. Might be too costly, too time-consuming, for all those reasons. So we want to take a subset. It says with proper sampling methods based on a sample of 1,500 adults, we can almost certainly estimate to within 3% the percentage of the entire population who have a certain trait or opinion. Now again, if you were taking a regular statistics course, you would learn how to calculate this, but in a minute, you'll see that it's just a very brief calculation that we're going to be using in this course. We're not going to be doing anything more sophisticated that you would learn in a statistics course. So we'll find out where do they come up with this 3%. It says here the result does not depend on how large the population is. So here, if we go back, when they say within 3%, that 3% is what's called the margin of error. For example, let me just give you an example. If you did a current poll, let's say it's a scientific poll of people who either support Donald Trump or Joe Biden. Let's say, let's just look at Donald Trump, for example. Let's say it's 45% support Donald Trump. That's the result of 1,500 adults. Let's say it's a sample 1,500. Okay. What we're basically saying is that we're almost sure that the true percentage of the population is the 45% you came up with plus or minus the 3%. That's called the margin of error. So we take the 45%, the result that we got from the sample, and we would subtract 3%. That gives us 42%. And then we would add 3%, which gives us 48%. And therefore, we would say that we're almost certain that the true population percentage who support Donald Trump is between 42% and 48%. This is basically the result that you get, the sample result, plus or minus the margin of error. Now, how do we calculate the margin of error? Again, we're using a kind of a crude method here. Again, not exactly what we learned in a statistics book, but this worked pretty well. It says for a properly conducted sample survey, the sample proportion differs from the population proportion by more than the margin of error less than 5% of the time. Okay. Well, we'll see an example of this in a minute. Now, 5%, by the way, means in fewer than 1 in 20 surveys. If you take 1 and divide by 20, you're going to get 0.05, which is 5%. And here's the formula. This is the formula right here. 1 divided by the square root of n is the margin of error. Now, what is small n here? That is the sample. That's the number of people in your sample. We call that, by the way, sample size. So if you ever hear me talk about sample size, it's the number of people in the sample. And that's what n is. So you take the number 1 and you divide it by the square root of the sample size, and that gives you, and then you express it as a, it'll come out as a decimal, and then if you want to express it as a percentage, you just multiply it by 100. But let's see an example of this. Suppose you had a sample of size 1600. In other words, there were 1600, n is equals 1600 people in your, that were asked some question in your survey. All right, so you took a survey of 1600 people, you asked them some question, okay? And you come up with a percentage of those people who answered a certain way. So for again an example, if there were 1600 people who were surveyed and were asked what percentage were asked if you support Donald Trump versus Joe Biden. Let's say it was 45%. So 45% supported Donald Trump. So that's the sample result. How do we know what the population result would be? Well, if there's 1,600 people who were surveyed, we would use this formula, 1 divided by the square root of 1,600, which is 1 divided by 40, and we would come up with 0.025. So 1 divided by the square root of n, or the square root of 1,600, is 0.025. Now, if you take that and multiply it by 100, you get 2.5%. So if 45% of people support Donald Trump in the sample, and you want to say something about the population, then you would take this 2.5% and add and subtract it from 45%. Which would mean 42% when you subtract, and 47.5% when you add. So you'd say that between 42.5% and 47.5% of between those two numbers is the true percentage of people who support Donald Trump. Now, in this particular example here, this is a different example, by the way. I'm just showing you how it works. In this case here, this particular case, they were asking the people, do you support the president's economic plan? So suppose this is another question on the same survey. And suppose 55% of the respondents said they do. They support the president's economic plan. It's the same 1,600 people. So what do? This is the sample result, 55%. And we want to say, well, what's the estimate of the population that support the economic plan? Well, we don't know for sure, but what we can do is take the sample result of 55% and then add and subtract this so-called margin of error. So we're going to take 55% and add and subtract 2.5%. And when we subtract it, 55 minus 2.5, we get 52.5%. 55 plus 2.5 gives us 57.5%. Then we could say we're almost certain, we'll never be totally certain, but we're almost certain that the population support for the president's economic plan is somewhere between 52.5% and 57.5%. In other words, we're saying somewhere in between these two numbers is the true population percentage of people who support the president's economic plan. All right. So we can ask, of course, for the same 1,600 people, all sorts of questions and get these, a percentage of people who say yes or no, and then we'll use the same logic, taking the result and subtracting the 2.5%. Where did he get the 2.5%? It came from the size of the sample. That determines your so-called margin of error. Now look at this little statement down here. Such intervals miss covering truth about 1 in 20 times. Now what does that mean? Well, let's look at this interval here. This is an interval because we're saying the true population percentage of people who support the president's economic plan is between 52.5 and 57.5%. Is there a chance we're wrong? And the answer to this question is yes, there's a chance. But what chance is it? A 5% chance. A 5% chance that we're wrong. Where did we come up with 5%? Because this formula assumes that in 1 in 20 times, which is 5% of the time, okay, we're going to be wrong. Okay? That's what this formula is assuming. That 95% of the time we'll be right, 5% of the time we'll be wrong. Okay? And that's what 1 divided by square root of n is assuming. Now, you're not learning about any other percentages, and if you're taking a true statistics course, we could say, let's come up with a formula so that we're wrong only 1% of the time, or 10% of the time. Well, we could come up with formulas like that, but again, for this course, we're not supposed to be learning how to do those more advanced formulas. In this course, we're sticking with simpler formulas. So this is the only formula that you need to know right now for this course when we talk about margin of error. 1 divided by the square root of n, where n is the sample size. And when we add that margin of error and subtract it from the sample result that we get, and get this so-called interval, in this case between 52.5 and 57.5, this is telling us that we might be right about saying that the true population mean is in between these two. We might be right 95% of the time. We may be wrong 5% of the time. Okay. Hopefully that wasn't too confusing, but that's about all I'll say about, at least in this point in time, in terms of margin of error. The whole idea, by the way, is that when we do a sample, because it's a subset of the whole population, the result that we get will probably not be the same number as if we had done a census. If we had actually asked everyone in the population, we would get a different percentage. The question is, how close is the sample result to the true population result? And the answer is, if we use this formula here, it depends on the sample. It depends on how big the sample is. Okay. And I hope you can see here, if you look at this formula, that the larger the sample size is, the larger n is, the smaller this ratio is, which means the smaller the margin of error. So how do we get a more accurate estimate, one that's closer to the true population result? We just increase the number of people in our sample. So the larger the sample size, the more narrow this range is, more narrow this interval is, and the better is our estimate from the sample. So just remember that also. The larger the sample size, the better the sample result is as an estimate of the population. Here's another example. 3 factors key for drug use in kids. 1,987 children were surveyed, ages 12 to 17. And 504 parents also were surveyed. We want to know what margin of error we can use for these results. Well, we just simply take 1 divided by the square root of the sample size. And notice when we do that, 1 divided by the square root of 1987, if we're dealing strictly with the children who were surveyed, our margin of error is going to be, whatever we're measuring, is going to be 2.2%. Take these two numbers, divide them, we get 0.0224. That's approximately 2.2%. For the parents, it's a smaller sample, and notice it's a larger margin of error, 4.45%. Okay, sorry about that. So, suppose the result is that 20% of the children said that they would buy marijuana in an hour or less. So suppose that was a question that was asked, 20%. Right. So that's a survey of 1,987 children. And if we wanted to generalize this to the whole population, we would come up with this interval of the percentage of children. Thus, we would take our 20% and add and subtract 2.2%. When we do that, we get approximately 18% when we subtract 20 minus 2.2. That's 17.8, but they rounded it to the nearest whole number, 18. And the 22% is 20% plus 2.2. Again, rounding it to the nearest whole number, they get 22%. So they're saying here, we are fairly confident that somewhere between 18 and 22% of all teens in the population, represented by those in the survey, would respond that way if they were asked. In other words, they would say, if they bought, they would 18 to 20% of all teens would say they bought marijuana in an hour or less. All right, so that's the idea of using a margin of error. Now, why do we even bring this up is because political polls, and again, this is an election that we're running into now. You'll hear, again, a political poll, and sometimes the news media will say, here's the result, 45% or 48% or 52% say yes or no to some question, and then they said, and the margin of error is, and they give a small percent. That is where they get that, the margin of error from. They use a formula like this. Okay. All right, what are other advantages of sample surveys? Now, what we just discovered is that we can have a small sample relative to the size of the population, and we can actually make a statement about the population. That's pretty good. Other advantages of sample surveys: when measurements destroy the units being tested, a census is not feasible. Well, let's think about that. All right. Suppose you are you're a manufacturing manager or something, or taking care of an assembly line for some product that's being produced, and you want to check for defects. Well, you're not going to open up every box and check for a defect. So what are you going to do? You're going to open up a small number of boxes, randomly select a small number of boxes. Well, when you do that, that box is it. That product, you can't sell it now. You're not just going to close it back up and sell it. You're not going to do that. So when you do measurements, sampling like that, you won't have the result for every single box off the assembly line. So you need to do a random sample. You can't do the census. It's also faster to collect a sample than the census if the population is large. And you can devote more resources to getting the most accurate information from a sample. It's much cheaper. All right, let's talk about sampling itself, what's called probability sampling. Now, that formula that I showed you earlier for the margin of error, 1 divided by the square root of n, it assumes the following. It assumes that we did a probability sampling. All right, it's not a sampling based off of volunteers. It's not a sampling that was convenient. It's called probability sampling. All right. And what's probability sampling imply? It implies that everyone in the population has the same chance of being selected in the sample. Make sure you know that. All right. Every person in the population has the same chance of being selected for the sample. That's called probability sampling. And how do we do probability sampling? Well, you've probably already done it at one time or another in your life. Let's say you wanted to randomly select somebody out of a group of people to run an errand or do something. What do? You write their names on pieces of paper, you put the pieces of paper in a box, you mix them up with your hand, and you randomly pick a person out of the box. All right? That's probability sampling. That's random sampling. All right. Now we don't, people don't do that, obviously. They use some computer software to do that now. But in essence, that's all it is. And when, if you put those individual pieces of paper in a box, each piece of paper in that box has an equal chance of being selected by you when you reach your hand in and pull out the paper. So in that same way, when a random sample or probability sample is done, each person in the population has an equal chance of being selected for the sample. Now, there are different types of probability or random samples. And the most, and the one that's simplest to understand, and the word simple is in there in its name, it's called simple random sample. Now, all these random samples I'm referring to all have this condition, that each person in the population has the same chance of being selected into the sample. A simple random sample has an additional criteria. And that's, let's say we were going to select 100 people out of a population of 10,000 people. Let's say it's a college that has 10,000 people. We're selecting 100 students randomly. A simple random sample has the following property. It's that every possible group of 100 students that we could select from those 10,000 total students, every conceivable group of 100 students has the same chance of being the sample that's selected. Let's assume, I'm just going to make this up. Let's assume there's 100 million different possible samples of size 100 out of a population of 10,000. Okay? There's 100 million of those possible samples. That means every one of those 100 million samples of size 100 has an equal chance of being the sample that is actually chosen by you when you select those 100 people from the population. All right? This is called a simple random sample. What do you need for a simple random sample? Basically, a list of all the units in the population, and there's a sampling frame. All right? And then you need some way of assigning random numbers to those people. All right? Again, putting their names into a hat. Well, if you have 1 million, that's not going to work very well. Or you use some computer program that generates what are called random numbers. And then you assign numbers to each person in the population, each person in the list, and then you randomly select those numbers. And then the people who are assigned those numbers are the ones selected for the sample. So this is called a simple random sample. So let's do an example. 200 students are in your class. That's the population in this case, 200 students in your class. You plan to take a simple random sample of 25 of those 200 students. First of all, what is the margin of error? 1 divided by the square root of 25. Notice I don't put 200 in here, I put 25. That's the actual size of the sample, not the population. That's 1 divided by 5, or 0.20, or 20%. So your margin of error is 20%. Okay, so that's your calculation for that. So step number 1, to do a simple random sample, you need a list of those 200 students, and you assign them numbers 1 to 200. And then you use some sort of random number generator and pick 25 numbers between 1 and 200. Makes sense, right? There's 200 people in the population, assign them numbers 1 to 200, and then pick 25 random numbers, and those students who have or who have been assigned those numbers that are picked, those 25 numbers, are the people that are going to be in the sample. So then you just locate those people, interview them, and then you have your results. Pretty easy. Now, since a simple random sample is the easiest type of sampling procedure, but sometimes it's not the most effective or efficient way of sampling. So we have these other methods here that are listed. One method is called stratified random sampling. What is stratified random sampling? You take your population and you break it up into non-overlapping groups. That is, let's say there's some natural grouping of the population. Suppose you had students in a school district. Let's say they were high school students. And suppose there were 5 high schools in the school district. So the high schools could be considered to be the groups. So you're breaking up the population of students in the school district into 5 groups, which are naturally there anyway, and they are the 5 high schools. Now they use the word strata instead of group, but strata means group. And what you do then is within each of those groups, you do a simple random sample. Now why would you want to do that? Well, for example, if the 5 high schools, let's say the 5 high schools, each of 4 of those high schools, each one of those, the 4 largest high schools had at least 1,000 students in it. And suppose the 5th high school had only 100 students in it, so it was much smaller than the other 4 high schools. You might want to guarantee that the small high school is represented in the sample. So what do? You do a stratified random sample, so that you do a simple random sample in each of those high schools, so that you at least one person in your sample from the small high school. All right. So how do you do? So what's the advantage? Well, of doing stratified random sampling, in addition to what I just said? Well, one advantage is that you, in addition to getting information about all the students, you also get information about the students in each group. In my example, in each high school. So you can summarize your results for each school. That's number one. Number two, if the variable measure gives more consistent values within each strata than within the population, you can get more accurate estimates of population values. In other words, if the school the results in the school tend to be similar because the students are learning from the same teachers and all that, then it makes sense to break up the data into these groups of schools because each school is similar. Number three, if the strata, or in this case schools, are geographically separated from each other, it may be cheaper to sample them separately. Number four, you can use different interviewers within each group sample. So you can have an interviewer for high school number 1, another interviewer for high school number 2, so forth. That's stratified sampling. What it is, and let me just summarize it again. You take your population, you break it up into groups, non-overlapping groups, and then you do a simple random sample within each group. Cluster sampling is similar to stratified sampling in terms of breaking the population up into groups, but in this case, we're not taking a random sample within each group, we're taking a random sample of the clusters themselves, the groups themselves. We're not going to choose all the clusters, we're going to only choose some of them. So we randomly select the groups or clusters, and the example I gave, just randomly select maybe 2 or 3 high schools, and then you measure everyone in each group. Right, so this is called cluster sampling. So what's the advantage? Well, you only need a list of clusters, not a list of all individuals. Suppose you That example I said earlier, where the Bureau of Labor Statistics was doing their sampling frame was a list of households. You could consider the households to be clusters. What is a household? It's a group of people, right? But let's assume that we don't want to take a simple random sample within each cluster. Suppose we just want to take a random. We want to take a random. We want to randomize the clusters. In other words, we want to take a random sample of clusters. Suppose that's all we have. We don't know who's in each household, so we can't really take a simple random sample within each household. It would be easier if we had a list of only households, just take a simple random sample of households. And then once we have that simple random sample, then we just interview everybody in each household. That's called cluster sampling. All right. Here's another example down here. All right, so we want to take a sample of students living in a dorm at a college. Suppose that the college has 30 dorms. Each dorm has 6 floors. So there's a total of 180 floors in total in all of these dorms. So what do? One way of taking the sample of students is take a random sample of floors. In other words, instead of taking a random sample of students, you take a random sample of floors. So out of 180 floors, suppose you choose 20 or 30 of those floors. So you random select 20 or 30 floors out of the total of 180 floors out of the 30 dorms. And then within each of those selected floors, you interview every single student on that floor. And that is what's another example of cluster sampling. So cluster sampling, you break your population into groups. You take a random sample of the groups. All right, so you select randomly only some of those groups, and then you select every person in that group to be in the survey. So I hope you can see the difference between stratified and cluster sampling. Stratified sampling, you're breaking the population into groups. You're taking a simple random sample within each group. A cluster sample, again, you break the population into groups, but you're taking a simple random sample of the groups and then selecting everyone in the selected groups. Systematic sampling is where we take the population and take the population list and we divide it into consecutive segments. So for example, we may have, let's look at the example down here. We may have 5,000 names on a list. And we want a sample of 100 people from that list. Now, do we just take the first 100 people off the list? Well, that's not random, is it? That's just a convenient thing to do, so it's non-random. How do we make it random? Well, if there's 5,000 names in the list and we want 100 people in the sample, we just take 5,000 and divide it by the number that we want in the sample. 5,000 divided by 100 is 50. So we take our list and break it up into 50 consecutive segments. 50 consecutive segments, all right? How many are in each segment? 100. 100 people in each segment. And what do we do? In the very first segment, we randomly select, now there's 100 of these segments. There's 50, right? So 5,000 names divided by 100, all right, gives us 50, right? So, and I think I might have gotten this backwards. I apologize, but so when you divide 5,000 by 100, we get 100. We get 50. What 50 is the number of names in each of the segments. So we divide the list into 100 consecutive segments of each of them of size 50. And what do we do now? We take the first segment, which has 50 students in them, 50 names in them, and we randomly select a number from 1 to 50. let's say we select the number 25. All right, just randomly select the number from 1 to 50, and suppose it's 25. And then what do? We find, and then for the next 100 or so, we now pick next person, 100 people after 50, and then 100 people after, I'm sorry, let me say it again. So we randomly choose a number between 1 and 50, and suppose the number is 25. And then we pick then the 25th person in each segment until we get to 100 people. All right. I hope I didn't confuse you, but I'm not going to ask you to do this mathematically. Just know that systematic sampling is where you break the population into consecutive segments, and then you pick a random number in the first segment, and then you take whatever that number is, whatever that position is in that first segment, it's the same position you pick in every other segment going forward. And then you'll get your sample. All right. Random digit dialing, you don't need to know too much about this. Just know it's a method that's used for phone systems to be called, for phones to be called by a particular system. So random digit dialing, it explains it here. You don't need to know much about it, so I'm not going to spend any time on that. All right, and this is just an example here of random digit dialing. All right, look through it. Just know what it is. It's basically a method to choose a random sample via telephone. Another term that's used in sampling is called multi-stage sampling. Multi-stage sampling uses a combination of some of the sampling procedures that we've just talked about. For example, U.S. government sometimes, the Census Bureau and maybe the Bureau of Labor Statistics might do a survey, and they may stratify by region of the country. For example, they might break up the United States into 4 or 6 or 8 regions. So they stratify by region of the country. Then they do another stratification within each of those regions by urban, suburban, and rural. Then they take within each of those areas, then they might do a simple random sample of communities. And then they might divide those communities into city blocks, which are clusters. And then they take a random sample of the clusters. And then once they have these random sample of these communities, then they might sample everyone in those communities. So it can get quite complicated. For this course, the only thing that multi-stage sampling should indicate to you is that they may do more than one level of sampling. And they may use different sampling methods, such as stratified sampling, cluster sampling, simple random sampling. So let's just go back for a minute and just do a quick summary. We have the sampling methods. We have our simple random sample, where we literally just do a random sample from a list, okay? Like taking paper out of a box. We have stratified sampling, where we take our population and break it up into groups and do a simple random sample within each group. We have cluster samplings. So cluster sampling, where we take the population and break it up into groups and take a random sample of groups and then interview everybody within each of those selected groups or clusters. Systematic sampling, we take our population and break it up into segments of the same size, same number of people in each segment. We take a random, we find a random number within the first segment, and then whatever number we pick there, we're going to pick the same number at the same position in each segment from that point forward. So if we had, again, boxes off of assembly line, And let's say we have 5,000 boxes off of an assembly line, and we want to examine 100 of them to see if there's any defects. We would divide the 5,000 boxes off the assembly line into 100 segments of 50 boxes apiece. So the first 50 boxes, the second 50 boxes, all the way up to the 100th set of 50 boxes. And then we would select a number from 1 to 50, and let's just come up with another number. When we select a number from 1 to 50, we pick 33. So the 33rd box off the assembly line would be the first box that would be chosen to check for defects. And then when we get to the second group of 50 boxes, again, we would select the same box from the second group, okay? I said the 33rd box off the first 50, and then the second 50 would pick the 33rd box off the third group of 50, all the way up to the last group of 50. And then we would have 100 boxes in our sample to check for defects. So this is called systematic sampling. And then we have random digits dialing, which is a way of getting a random sample through phones. And then we have multi-stage sampling. All right, now, the other type of sampling I wanted to mention, the non-probability sampling, is called convenience sampling, or haphazard sampling, or volunteer sampling, or self-selected sampling. All of these words really mean non-probability sampling, non-random sampling. And when you have non-random sampling, you can never take the results and say something about the population. You can't find a margin of error. You can't estimate anything about the population. As simple as that. All right? So that's a disaster, right, if you use one of these types of sampling procedures. They also mentioned other difficulties in sampling. What if the sampling frame, that's your list of people or things from the population, suppose your sampling frame isn't right. Suppose it includes people that shouldn't be there, or excludes people that should be there. Sampling frame is wrong. In the last election, 2016 presidential election, many of the polls were wrong, predicting Hillary Clinton would win. And it's probably because the sampling frame was not accurate. A lot of people who voted for Donald Trump were not being considered as part of the sampling frame. So if the sampling frame doesn't have the correct people in them, correct population, then even if you did the random sampling perfectly, the results could be incorrect. Another possible problem also is you're not reaching the people that you selected. They didn't answer, or they're not there. And also, some people refuse to be interviewed. You may have a very low response rate from calling people or contacting them. All right, so again, here's some information here on the slide about using the wrong sampling frame. Okay, again, as I said earlier, the sampling frame might include unwanted units, unwanted people who were not the ones that you're interested in, or it may exclude people that you're interested in. Okay. What's an example? Let's say you wanted a list of people in a certain town, and you you got a list, and that list might include people who are just there in that town temporarily. They shouldn't be considered. And it may exclude people who might be traveling. So you're excluding people that should be in the list, and you're including people who shouldn't be in the list. So that's an example of having the wrong sampling frame. Not reaching the individual selected. Okay. Here's an example here. Sometimes sometimes it says here, sometimes telephone surveys reach a disproportionate number of women because they are more likely to answer the phone. I don't know if that's true today. This might have been true 10 years ago. But so there's ways around these things, but that's an issue. All right? You may, again, get a disproportionate number of people, belong to a certain group, and you're missing other people that you would want to actually contact. The so-called quickie polls, the ones that are done overnight or anything like that, those that typically are not randomly selected people. And they're poorly tested, and they're not good. They don't represent the population. Low response rate, that is a real problem in today's world with surveys. The lower the response rate, as it says in the second bullet point, the lower the response rate, the less results can be generalized to the population. All right? So that is an absolute problem. Survey response is voluntary. Those who respond likely have stronger opinions than those who do not respond. You may end up with biased results that are biased towards people with a certain type of opinion, and you're leaving out people who don't have that opinion. All right. Here's an example of a meaningless poll. All right. Versus a poll that is more meaningful. TV poll, a pop-up poll that was done. Question is, do you support the president's economic plan? TV poll, a volunteer sample. All right, these are people who have strong opinions. They have strong opinions, in this case is no. 58% said no, I don't support the president's economic plan. But if you did a properly done random sample, you might find it switched. You might find that 75% of the population say they approve of the presidential economic plan, and only 18% don't. So that's why random sampling is important. Random sampling allows you to take the results and estimate, by adding and subtracting that margin of error, estimate the true population percentage. A volunteer sample or a sample that's not based on probability, you can't generalize that to the general population. Right. Number one, you can't calculate a margin of error, and number two, the results are biased normally. So, using the most convenient group available or deciding on the spot who to sample can produce misleading results, as we saw here. Okay. And then I'm going to wrap up in a minute. This is a pretty long video, so I think I'm going to wrap up. But go through and read chapter 4. Everything I'm covering today is there. Hopefully this video helped. Let me go over this one. This is a famous poll that was done. This is the election in 1936, and the Democratic president at the time was Franklin Delano Roosevelt, and his opponent was Republican Alf Landon. So Roosevelt was a Democrat, Alf Landon was Republican. So there was a well-known magazine back there called the Literary Digest. It had 10 million subscribers. Back then, that was a huge number of people. And so they sent questionnaires to 10 million people from the magazine subscriber lists and phone directories, car owners, who were more. And so they not only sent these surveys to their questionnaires to their subscribers, but also to others who were probably more wealthy and probably not happy with the what Franklin Roosevelt was doing for poor people. So anyway, out of those 10 million people, they got 2.3 million responses, a low response rate, but still 2.3 million people. And they had very strong feelings about the way the economy should be run. And they liked Alf Landon. They predicted by 3-2 that Landon was going to win big. There's another guy named George Gallup. He was this young guy, pretty much fresh out of college, had no real background in polling, but he thought about it and he used random sampling. He had a much smaller sample than the Literary Digest. His sample was only 50,000 people. And he got that and did the random sample out of a list of all registered voters. All right. So he also took, just interestingly, he took a random sample of 3,000 people from the lists of the Literary Digest, just for fun. Well, with his sample of 50,000 people, he predicted Roosevelt would win big, complete opposite of what Literary Digest said. And he predicted accurately using random sampling. And Literary Digest was completely wrong. And it's interesting that he used, when he did the 3,000 people from the Literary Digest list, he came up with the results similar to what the Literary Digest came up with. But the Literary Digest lists are all people who didn't like, were basically Republicans. They didn't like the Democrat Franklin Delano Roosevelt. So it was biased. That list was biased. It wasn't a representative sample. His random sample of 50,000 people from all registered voters, that was unbiased, and it was a random sample. Okay, so when you have a true random sample, using one of the random sampling methods that I mentioned, simple random sample, stratified sampling, cluster sampling, systematic sampling, any of those sampling procedures, you're going to get a fairly accurate, if your sample size is large enough, you're going to get a fairly accurate estimate of the population value. Use a biased list, like this list here from the Literary Digest, or if you use convenient sampling or voluntary sampling, you're going to get, there's a good chance you're going to get biased results and inaccurate results. Okay, so that is it. And anyway, this is the review of random sampling, chapter number 4. I apologize for it to be so long, but I hope you got something out of it. You can, of course, listen to this more than once. I will, again, this is going to be posted in Canvas, so you can listen to it over and over again. All right, so that's it. And then we'll be moving into chapter 5, I believe, next week. And let me just take a quick look at the textbook. Chapter 5 is on experiments and observational studies, where we go through a little more detail in the vocabulary of experimentation. So that will be covered on the following Tuesday, the 21st. And do remember that there is a quiz that day also on the that will cover the vocabulary from the first 4 chapters. All right, that's it. I'm going to say goodbye now and see you on Monday, the 21st. Okay, so that's it. Take care. Bye-bye.